What's up, CNC woodworkers? My name's Corbin Dunn, and this is a small series on how to create this epoxy drip bowl with a CNC machine. In the last two episodes, I showed how to design the bowl in Fusion 360, some computer-aided design for the basic shape, and then an episode on how to actually do the mold with the bumpy pattern to pour epoxy into and use as a blank for machining out the actual bowl shape. In this episode, I'm going to discuss the Toolpaths or the CAM, the computer-aided manufacturing. So how to actually go ahead and create the toolpaths to make this shape and the mold shape. So let's jump into it. So the first thing I do is switch from the design phase to the manufacturing phase inside Fusion 360. From there, the first thing you always have to do is create a setup. So I hit Setup, New Setup, and here we're going to do the setup for the mold first. The important things that we want to take a look at are going to be the stock. So I select the stock, and I go down, and for the mode, we want a relative size box with no additional stock. This is because we're going to create a rough size piece of this specific size out of wood and start that as our base. I then select the stock origin as the top left portion because that's just my standard of what I like to do. I then rename the stock because we want good organization and practice. The first thing we're going to do is create a pocket clearing. Pocket clearing works from the top downwards. 3D Adaptive is much faster, but pocket clearing works better for stuff like this to avoid chip out in the wood. I'm going to select a 3/8 of an inch spiral upcutting bit to remove the most of the waste. Check out the description to see the exact bit that I'm using and more details on it. One of the first things I like to select is the shaft and holder with a fail on collision. This way in software it'll tell me if the bit or the holding portion of the bit is going to actually hit something and stop and alert me that there's going to be a problem. Next, I generally like to select a stock contour. This just helps limit where we're going to be machining. Finally, I like to go ahead and set stock to leave to be about 0.010 of an inch. This gets us a little bit finer of a detail that we can clean up with a finishing bit. The maximum roughing step down is 0.03 of an inch, which is the default. So I take a look at the toolpath that this generated, and it looks like it's not going to do a lot of stuff. It's not going quite as deep as I'd like. So I'm going to go ahead and right click on the toolpath and select Edit. Go back over to my passes, and I want the passes to be about 100 thousandths, and then hit OK and see what this does. You could do 50 thousandths of an inch or half this to get a little bit finer and more detail, and it will create less chip out on some of the top of the mountains. So if you're getting chip out, use a smaller step down on your roughing pass. Disadvantage is it takes longer. From the looks of the toolpath in the preview, it seems okay. I could go ahead and simulate it and take a quick look and see what the simulation is going to be like. Standard things I do on simulation, I want the toolpath to show the tail, and I want the mode to be standard, and I usually check stop on collision so I'm alerted to any collisions that might happen. After that, I go back and create a derived operation to do some more pocket clearing, and the purpose here is to just get a little bit more detail with a different bit. So I select a 1/4 inch spiral upcutting bit. I could just do all of this with a 1/4 inch spiral upcutting bit, but the 3/8 of an inch bit seems to be a little bit faster, and then I toss in my 1/4 inch bit to do a little bit more finer detail. The only trick that you have to do is to make sure you select rest machining, otherwise the 1/4 inch bit is going to do the exact same toolpath that the 3/8 inch did, and we don't need to do that. So from there I can see the 1/4 inch bit will get me a little bit deeper in some of the pockets and give me a little bit more detail, which will be nice. So next I need to do the finishing pass. So from the 3D machining tab, I'm going to go ahead and select a 3D contour. For my finishing passes, I'm going to use a ball end nose, and specifically it's a spiral upcutting 1/4 inch ball end nose. The 1/4 inch gives enough detail for this particular operation, but I could use a different bit to get more detail. So as before, I'm going to select shaft and holder, fail on collision again. And notice I'm not really talking about speeds and feeds. I'm using a Toolpath PCNC 1100, which is a better machine suited for metal, and it's rather limited in RPMs for wood. So really my wood speeds and feeds are kind of just specific to my machine, and if you have questions about speeds and feeds, please comment below and I can try and help answer some questions. So I go over to the passes tab, and the only parameter I like to change is the maximum step down. The default here is 40 thousandths of an inch, and to get a finer detail where you don't have to sand a lot, I change it to about 10 thousandths of an inch. You can do a little bit finer, like 7 thousandths, and I go finer if it's a really hard wood or if I'm doing epoxy and want a better finish, but for cherry, 10 thousandths of an inch works pretty well. So once the toolpath generation is done, I can go ahead and do some simulation and see how well this will work out. One of the things that I'm noticing is that the first operations are kind of like leaving little mountaintops, and once I get to the spiral upcut ball end nose, the finishing phase, I'm getting some collisions. And it's not really a big deal because the mountains that are being machined in the prior roughing passes left a little bit too high of an area, and so it's going to just collide with it a little bit. But for wood, it's not a big deal, and the depth of what it's doing doesn't seem to be causing issues. If I wanted to eliminate this, I could do a finer step down in that first roughing bit pass and not have this issue. So I do a little bit more simulation and just make sure everything looks okay, make sure any of these collisions that I'm seeing here aren't going to really be a big deal. Alright, so now into the bowl cam. So now we want to go ahead and hide the stock and then go ahead and expose the bowl body, or actually the bowl component, and create a new setup. The interesting things here is we want to make sure the body for the bowl is selected. So I go over and expand the outline view for the bowl and make sure the body is currently selected. Next thing, I want to set up the stock for this item, and I'm going to go over to the stock tab. I'm going to drop down the list and select from solid, expand the stock item, and then I'm going to select the square stock body, which is the basic size of what we're starting the machining with. Next, I need to set the origin, and for now I'm going to set it to be the top left, but we're going to change this in just a second, and I'll explain why in a brief moment. So I want to do the bottom of the bowl first, so I'm going to name this operation bowl bottom, and I want to go ahead and flip the bowl around to the back side of it, and I generally want to keep the orientation of stuff consistent. And so I find it easiest to create a new name view and then name this the bottom cam view so I can go back to it really easily. Once I've done that, I can go ahead and re-edit that bowl bottom setup. I right click on it and select edit. Now I want to change the stock point to be this other origin. When I just select it, the axis orientation is obviously not correct. So I want to select the z-axis next plane. So go ahead and flip these around until I get that top left point to be the origin for my machining operations. And this is just my preference. I like this top left point because it's really easy to indicate in. So everything looks right, and that's our orientation for doing this machining. Okay, so now it's time to do some of the tool paths. In general, I'm going to do a roughing operation with a 3/8 of an inch end mill, and then the final operation with a 1/4 inch ball and nose mill. So the first thing I do is create a 2D face, and the reason why I'm going to do the facing is I want the bottom to be perfectly flat. I can just use the 3/8 of an inch bit that I'm going to be doing my roughing operation with, and go ahead and do a facing operation with that bit. What this will do is create the bowl bottom to be perfectly flat. So the next thing I want to do is create a roughing operation for the outside of the bowl shape. I'm going to go ahead and do a 3D adaptive clearing for this roughing operation. I'm going to select my 3/8 of an inch end mill, a spiral upcut end mill, and this will be good to remove a lot of the waste really quickly. Again, like before, I'm going to select the shaft and holder and make sure fail on collision is selected, so in software it can detect if it's going to actually hit anything. I'm going to set the stock contours, and I'm not going to do anything special for the heights or the passes. The roughing step down is 300 thousandths and the fine step down is 30 thousandths. Those are the important things to look at. Also note, I have stock to leave set to the defaults of 20 thousandths. So the next thing I want to do is create a 2D contour around the whole stock. And the reason I want to do this is because we want the machining to be, basically we want to create a perfect square shape or rectangle around our stock piece. And we're going to start out with something we cut on the table saw, which may not be a perfect square. If we machine out the outside to be a perfect square, then we can use that to indicate in on the second operation and know exactly where everything's going to be. So the way I do this is I'm going to go ahead and create a 2D contour around the base for the stock size. I'm going to take that and inset it just slightly, and the amount that I inset it is going to be our origin offset for the second operation that we're going to do. So I go ahead and select 2D contour. I'm going to use that same 3/8 of an inch bit. I'm going to show that stock again, and then I'm going to go ahead and select that stock contour as the thing we're going to machine. It's going to machine the selected contour's bottom height, so that's important to note. And here's the special part. The stock to leave for radial, I want to be basically negative 50 thousandths of an inch, axial 0. And so that's going to do a slight inset cut on the whole stock profile. So next I want to do the final operation, which is going to be a 3D contour. I'm going to select my 1/4 inch spiral upcut bit with a ball and nose, and I'm going to use that ball and nose bit to do the final outside passes. As usual, I select fail on collision for the shaft and holder. Then the main thing that we have to note are the heights. The heights are just going to be the whole model, and the maximum step down is the one thing we want to change. So I go from 40 thousandths to about 8 thousandths. And if you recall earlier, you did about 10 thousandths on the previous machining stuff. So here I'm going to go a little finer and do 8 thousandths because we have epoxy. Once all the toolpaths are generated, I like to make sure it's going to work. So I'm going to go ahead and select that main setup and do a simulation. As usual, I go to standard for the mode so we can do some collision detection and show just the tail operations of the toolpaths. Then I'm going to just walk through and make sure we don't get any collisions. So now it's time to do the top operation. So I go and select the home view to reorient everything. And I want to create a new setup for the top, but we're going to have to figure out where the origin is going to be. And doing that last profile cut, about 50 thousandths of an inch inside, is something we have to accommodate. So in order to accommodate that, I'm going to flip over back to the Design tab. The Design tab previously showed what we were working on before in the design mode. So I'm going to go ahead and expose the stock alone because I want to create my new origin for the top side of the stock to do the top operation of the bowl. So I hide the bowl and I show the stock. I show the square stock body. And now I'm going to right click on the square stock body and select Create Sketch to create a new sketch. From there, I want to create this new origin that's going to be inset by just a little bit. So this is going to be the origin for the second machining operation of the bowl, the second op origin. I'm going to go ahead and hit S, start typing point to select the point operation, and drop a point down in a random location here. hit D for dimension, and I dimension to the bottom for 50 thousandths of an inch, and dimension to the left for 50 thousandths of an inch. This would be a great location to use parametric design, but I'm not doing that now. So what I have here is a new origin that we can use, inset by 50 thousandths of an inch, which is that bottom path that we did in the first operation, the bowl. So next I flip back over to the manufacturer tab, and I want to create a new setup for the bowl top. So I hit setup, new setup, and I'm going to select the same stock, square stock body that I did before, and all we're going to modify is the origin. So the stock is a square stock body. The stock point, now I want to be able to select that thing on the sketch, and it's not showing up. So what we got to do is I'm going to display the stock, expand and make sure the sketches are visible. Then I can see that new origin point, and I can go ahead and click on the stock point, do selected point, and then select that workspace origin. From there, I see the X, Y, and Z axis is aligned the way that I like. So I'm going to not have to do anything to reorient the axes and just hit OK. So as usual for good organization, I rename my setup, and this is the top operation, second op. So we're going to do a facing operation like we did before to get the top to be exactly where we had it. I just select the previous one, copied it, and pasted it in to get into the next setup. I then copy and pasted the second operation with the tool to do the adaptive clearing. And one of the things that we're going to see right away is that this will generate some failures. And the failure message is going to be the shaft holder is going to collide with it because we had that shaft holder collision. It's colliding on the outside because it can't go inwards. So the way I'm going to deal with this, I'm going to right click on that operation for the roughing operation and hit edit. And we're going to just make it do the roughing operation down to the bottom of the lip of the bowl. And that way it'll get that round portion of the top and then stop. So I'm going to do my bottom height to just be the model top and then a bit lower to ensure it's actually lower than the lip. So I'm going to choose 250 thousandths, see if that's low enough, and it looks like 250 is a little too low. So we're going to go with like 200 thousandths. It probably could be just at the widest point, so it could probably be like 125 or so. So it generates the toolpath, and this time it doesn't have any collisions, which is great. So now I'm going to select that tool operation, and I want to create another one to do the rest because this is only going to 125 thousandths. So I'm going to copy and paste it and then edit it. And now we have to go back over to the Heights tab, and we're going to change the bottom to be the model bottom. So it's going to go and do all the way to the bottom of the inside of the bowl. But we're going to change the machining boundary to be the silhouette, so it won't do any more of the outside portion, which was done when it was upside down. So I went ahead and hit OK, and I see it generating the inside alone. And so I see it generating the toolpaths here. And what I'm noticing is that it's doing the top toolpath, which we already did, and it doesn't need to do that. We could turn on rest machining, or we could just turn the top height to be the model top minus 125 thousandths, which is the bottom of where that last operation did. So it's just going to complete what the last operation started. One other thing I like to turn on is the minimum retraction policy, just to save a little bit of time. So at this point I want to do my finishing pass with the ball end nose. So I just select my ball end nose path from the previous operation, hit copy, and then I'm going to paste it over into the new setup, and then we're going to tweak it a bit. I would expect, just like previous times, we would get a collision, but we might not be based on the operations that we have set. In fact, it actually looks like it's doing pretty good. But one of the things I can see right away is that it's not getting the bottom of the bowl, and so we need to figure out how to get that portion. So I'm going to go up to the top, hit 3D, and I'm going to do a 3D spiral for the bottom of the bowl to get that portion done. As usual, I'm going to turn on fail on collision for shaft and holder. I didn't have to do this for the others because I copy and pasted it where it was already set. The geometry, well, I'm just going to let it do the whole silhouette area as the machining boundary. And we're just going to set some slopes to limit the angles as to how high it will actually do this portion. And we basically want to machine just the flat portions here. So on that slope, I'm going to set the from slope to be 0, the complete flat portion, and the to slope, I don't want it to be vertical 90 degrees. I want to go to about 20 degrees and see how that ends up looking. So when I look at the toolpath, I can instantly see it's not going to be fine enough. It's going to leave a rough finish. So we need to increase the step over. So I'm going to right click on it, edit it, and go over to the passes tab and set the step over. For this particular operation, I'm going to do about 10 thousandths of an inch, which is just based on my experience. So once all the toolpaths are set up, I need to simulate both of them at the same time. And there's an easy way to do this in Fusion 360. All you have to do is you select those two setups, and if the two setups are selected, you can then go ahead and hit the simulate button, and it'll simulate both those setups back to back, which is great, because if we didn't do this, we'd probably get collisions. So I'm going to fast forward through the simulation of the first one, and all it's going to do is leave us with the base stock of what we would have for the second operation. And here, this is a perfect example of why I leave some bottom portion on the top of the bowl, or the bottom from the first operation, depending on how you looked at it. It's because we need something that we can indicate in. And so the start of the second operation is just going to be basically killing off the top portion, that little extra bit. So as we can see in the simulation, the top facing operation is going to probably generate it where there's like a little sliver of wood left over, especially if things aren't lined up perfectly. That's probably not a big deal. It might snap off a little bit, and it shouldn't cause an issue with this type of bowl. There are ways I mitigate it by doing other 3D adaptives to just to get it to machine it away without doing a facing op. And in this case, I'm just going to leave it as is because I don't think it's going to be a big deal. The other things to note, I just watch the whole simulation, make sure I don't get any collisions, and make sure it looks like it's machining it the way I want, not doing anything funny, and I will sometimes zoom in to make sure the finish is kind of what I'm looking for. But that's pretty much it. This is what I'm going to do from inside Fusion 360 for my toolpaths. I'll export them to my specific machine as NC files from my Tormac PCNC. The export's really specific to whatever machine you're using, so I'm not going to show how to do that. But if you have any questions on how to do it, just feel free to ask me, and I will happily help you. Stay tuned for the next episode where I'm going to cover the actual creation of this bowl in real life by cutting some wood, pouring epoxy, and machining it out. Thanks everyone. Subscribe and comment below. It encourages me to make more videos. Thanks.